So in this video we'll discuss about symmetric relations. Okay, so we have already done reflexive relation and irreflexive. Now we'll continue with symmetric relations. I hope you have watched these previous two videos, or you have knowledge, then you can watch this also. Yes, so another thing is, if any query is there, please mail me. This is my mail ID, SUDESHNA135@gmail.com. okay, so this is my mail ID. You can just, other than Facebook Messenger, you can text me anywhere, LinkedIn, Instagram, Telegram, my mail or WhatsApp, anything. Okay, so just not Facebook, because I don't see that. And if you love watching my videos, please do like the video, share with your friends, and at least please do subscribe. Okay, and click the bell icon. Okay, so I hope you do this. At least please do subscribe you. Okay, other if possible. Okay, thank you. So now let's move on to our this symmetric relations. Symmetric relation is a relation R is on a set A. A is our set, is said to be symmetric if X is related to Y. Okay, this is first is related to Y, then Y is related to X. If this is there, then this has to be there, the opposite one has to be there for all X and Y. So for all X and Y belongs to A. So that is, if the ordered pair X Y belongs to R, then X comma Y belongs to R. Okay, so now let's see some examples, then it will be clearer to you. So now here let's see, this is our set 1 2 3. Then now we have R1 as this relation 1 2, 1 is related to 2, so then 2 has to be related to 1. So this is our symmetric. Okay, so this is basically symmetric relation. So if this is present, 1 is related to 2 is present, then opposite one has to be present, 2 is related to 1. Okay, so that is our main basic thing here. So if X related to Y is present, then Y related to X has to be present. So this is symmetric. So now reflexive, this is not reflexive because none of the things related to itself is present. 1 1 2 2 3 3, nothing is present. It is irreflexive or not? What do you think? It is irreflexive because none of these are present. 1 1 2 2 3 3, nothing is present, so it is irreflexive. Next 1 1, so it is X related to Y, so A1 is related to 1, so it will opposite will be 1 related to 1 only, so this is symmetric. Okay, so now it is reflexive? No, it is not reflexive because all of this 2 2 3 3 they have to be present. Okay, again this not irreflexive also, any of this related to itself is present, then it is not irreflexive. So this is also false. Next is R3 2 3. So what is this? So this is symmetric is not possible because if 2 related to 3 is present, then 3 related to 2 has to be present, but it is not, so it is not symmetric. Then reflexive, it is also not reflexive because none of this 1 1 2 2 3 3 present, so it is not reflexive. And irreflexive, yes, it is irreflexive. Why? None of just thing 1 1 2 2 3 3, none of this is present, so it is irreflexive. Now next is 3 1 1 1. So 3 1 is present, but 1 3 is not present, so symmetric is not possible. Then reflexive, just 1 1 present, 2 2 3 3 not present, so it is not reflexive. Then irreflexive is also not possible because any one of related to itself is present, so it is also not reflexive. Now next come to empty set. Empty set, we know reflexive is not possible because the minimum things have to be present, that's what related to itself. And irreflexive is possible because none of the single related one X related to X is present, so irreflexive. But symmetric, yes, it is symmetric. The thing is, if this is present, then this has to be present. If this is not present, then nothing has to be present. Okay, so this is basic thing. If this, then this. If this is not present, then we don't have to check anything. So it is symmetric. So number 6 is largest, A into A. Everything will be present. So everything will be present. Then if it is related to Y, then it obviously the opposite one will be present, because it is the whole thing. A into A is the whole thing. So it is symmetric. Reflexive will be there because it's the largest, and irreflexive will not be possible because everything is present. So this 1 1 2 2 3 3 will be present. So irreflexive is not possible. So now our question is sorry, not question, the smallest relation which is symmetric is empty set. So we have seen this empty set, this is the smallest one. So smallest cardinality is 0 and the largest cardinality is 1. Everything is present. So the largest cardinality is n. Okay, I'm so sorry, largest cardinality is n square. I mean A into A, right? A into A is n into n, which is n square. Just misplaced 2, so it is n square. Okay. Next is number of symmetric relations. Okay, this is the number of symmetric relations. So we know that A cross A is consisting of, let's say A first, A is of n. Okay, then A cross n will contain like this. We have done, okay, previously also. Then 1 1 2 2 3 3 dot dot dot, let's say n cross n. Then let's say 1 2 is present, then 2 1, then 1 3 3 1, like this. Okay, so let's say this is going on. So next thing is total is n square, right? This is n, A into n will contain n square. So total is n square. We have seen this lot of times, and this part is n. So this part will give you n square minus n. So now we have to find out number of relations. So previously this part was either present or not present, so we are not considering this part, but here symmetric relations we have to consider this part may be present, may not be present. See, may be present or may not be present. Okay, so then it is 2 to the power n. And now let's see this part. Okay, so actually this is into, so let's see this. So we cannot just take the whole single element, so we have to make this a group. This 1 2, if 1 2 is present, 2 1 has to be present. That is our basic symmetric relation law. Okay, so if 1 3 is present, 3 1 has to be present. Like this we are grouping everything into 2. Okay, like these two elements are grouped together as a one element, so 2 are grouped together as 1. So if we continue this will be number of elements, n square minus n by 2, because everything is grouped together, 2 elements are grouped together, so it will come down to as this. So you can imagine this whole thing as a set of one element. Okay, so like this you can imagine like this. So now this can be present and cannot be present, same thing like this. Okay, so same thing like this. So if the whole thing can be present, cannot be present. Okay, so we are grouping these two as a single one, and we are combining this, and we can say either this can be present or cannot be present. So now it is saying 2 into n square minus n by 2. So it is coming as 2n plus n square minus n by 2. So 2n plus n square minus n, so 2 to the power n square plus n. Okay, so this is an important relation because this was asked I think many times. I have to see, but I don't know, I remember this why, maybe I have practiced or maybe some questions came. Okay, so I hope you have understood this. See, you can derive this at your exam. You don't have to remember all this because remembering all this is very hectic. Okay, very like reflexive, asymmetric, symmetric, antisymmetric, there are a lot of things. So I don't know if it's possible to remember, but you can derive it anyway, so it's easier this way. So I hope you have understood this. Let's see some examples. Now let's see some of these properties, okay, of symmetric relations. So the relation X is a brother of Y. So is a brother of Y. This is symmetric on set of all means. So yes, it is. If no all human beings were given, then it would have been false, because someone can be brother of Y, but this person can be a she, means woman, so she is a sister of that person X. But here it is given explicitly that it is all men. So if X is a brother of Y, Y will be a brother of X only. So this is true. If this would not have been present, then it would have been false, because if X is a brother of Y, it can happen that Y is a girl and Y can be sister of X. So it is important to look everywhere. Okay, so the next is the relation is parallel to, is symmetric on set of all lines. Okay, so if now you have two lines, so let's say this is parallel to this, then this is also parallel to this, right? Because they are both parallel to each other. So I hope you know parallel and all. So if this is parallel to this, then this will also be parallel to this. Okay, so this is also true. The relation is perpendicular to, is a symmetric on all lines. So for perpendicular you need two lines, so both way it is 90 degree. This line can be perpendicular to this, again this line can be perpendicular to this. Okay, so basically 90 degree angle whenever it is forming, it is perpendicular. So this, let's say this A, B, C, D. Okay, so AB is perpendicular to this line BC. BC can be perpendicular to this line AB. So this is also symmetrical. This is true. The relation less than equal to is not symmetric. So because here less than equal to is present, so something is less than B. Okay, so let's say take 1 is less than 2. 2 can never be less than 1. So this is not symmetric. So this is also true, not symmetric. Okay, so the relation subset is not symmetric on set of all sets, because something is a part of A is a part of B, subset of B. B cannot be a subset of A. Okay, so this is not possible. So this is not symmetric. I hope you have understood this. This is just basic concepts. You can use them if this something like this comes, and you can use them in exam. Now let's see this example. Okay, so first is every subset of a symmetric relation is symmetric. So this is not true. Okay, so why is it so? So let's say 1 2 is present, 2 1 has to be present, then 1 3 is present, and 3 1 has to be present, like this. If we take a subset of this, if we take these 3 as a subset, so this 3 is not being symmetric, because 1 3 is present, then 3 1 has to be present. So this is basically false. Okay, so now next is superset. Every superset is a symmetric relation in symmetric. Every superset of a symmetric relation is symmetric. Suppose this is our set given, and if we add, let's say 1 4. Okay, so if we add superset, means we are adding something. We have added here, and this is not symmetric, because if it is added, then we have to put 4 and 1, so which is not present. So this is not true. Okay, so this is false. Subset and superset are giving you false. Now if R and R2 are symmetric, then R1 intersection R2 is symmetric. This is true, because R1 is already symmetric, R2 is symmetric. If we take the intersection of this, we will get symmetric only. Okay, sorry, true. So similarly, if we take a union, obviously union will always be true because we are taking the union, nothing just coming out, just we are taking the union, so this will be true. And next is set difference. Set difference is also true because from symmetric we are taking some symmetric only, so this is also true. Okay, so I hope you have understood this. We will see next is our anti-symmetric. Okay, so I hope you now keep watching and keep practicing. Okay, so bye and see you in next video.